Testing. Testing 1 2 3. All right, hi. So today I decided to do a project I've been wanting to do. Oh, sorry, I turned my camera on for a while, which is to take the graphics of Missingno and load them into processing and make abstract music out of it. I figured I would just do this one live and then maybe I'll edit it into a more concise tutorial, since I will probably be sitting here Googling stuff on my other monitor while we're doing this to get some of the kinks on processing worked out. But to give you a basic idea of the process, in case I don't end up editing this down and it just gets the YouTube raw, the idea is that if we get a picture, and I will open Chrome, let's see here. Yeah, the idea is to take an original Game Boy image of Missingno from Google Images, and we'll do small. I guess medium is all we can do. So that way, we can use that as a 4-color GIF, and then load that data into processing, and then make some music with it. I got kind of an idea of how I want to do that, but again, this is probably going to be a little bit tedious, as programming usually is. So I'm just going to play some music basically while I do this, and then we'll see how it goes. So I'm gonna hop in. Hopefully I'm not gonna play it so loud that I can't still talk over it, but yeah, that's it. So enjoy. Hope if y'all have any questions, feel free to reach out. I'm glad to answer them. And I should say, like, the first part of my process here is to go again on Google Images and try to find a original. I think the Game Boy original resolution is like 140 by something. So let's just look that up real quick. Type in resolution 160 by 144. So that's really what we want to do. Let's look. Let's see. Bump, 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 bump. Yeah, we can't really search for a small picture. So okay, so actually this is the one I settled on before, because of the fact that it's not an original Game Boy screen cap, but you can tell that the pixels are 1-to-1 in terms of their size. You'll see why that's important in a little bit here. Okay, going here. So if you're like me, you remember missing numbers from the original Pokemon. I didn't know this until recently, but that there's like 3 or 4 different, well, I guess actually like a dozen or so, depending on which languages you had, versions of this rare, mysterious glitch Pokemon. So, yeah, this is, you can see as I open Photoshop here, is that the issue with all the other ones is that they're not actually giving us like pixel for pixel rips of the graphics. If we zoom way in here, and I get out like my brush tool, I guess, I don't know if you can see that, yeah. This actually has pixel accurate copies of the sprites. So then the first thing we're gonna do is crop down, I want to use, this is, to me, this one over here is like, that's Missingno, right? That's the one that I remember from the Pokemon games. I guess this is like, there was other ways to get the fossil Kabutops and Aerodactyl, and then this was like a Pokemon Yellow one, which the yellow one looks like it would be really good to do too. But we're not going to worry about that right now. And so I'm going to crop that down and just undo that and redo it for a second to look at our edges, because we have got one blank line down there. Is it, I don't know if the stream is still going. My computer said there was a network error, so we might just be talking to ourselves here. I'm kind of like okay with it, I guess. Alright. So now that we have our Missingno over here, I'm gonna export it as a GIF file, quick. And you know what? This is a good time. We're gonna start processing. So I get the basic idea behind this is to get this image of Missingno into processing so that we can extract like the pixel data. And in order to do that, one of the most important things we're going to look at is the dimensions. Now that we have it cropped down specifically to Missingno, we see it's 23. So width is 23, height is 56. Okay. So I'm going to go back into my processing and start just typing up a program for us here. And so up here I'm gonna say int, what were those values, int pix width, and then we're gonna do pix height. Now again, this is gonna be a little tedious. I'm kind of talking to myself over here, I know that, as far as the live stream goes, I mean. But the point is, yeah, again, that I'm gonna Google some stuff, because anybody who knows about programming knows that's an essential part. So I'll be cutting that out, I guess, in an edited version of this. So hopefully, we can figure out here. So the thing I learned the other day, or I guess I looked up, was that there's a thing called settings in processing that will let you define the resolution of your processing project by, it says if you need to have variables. So yeah, I'm curious about that. So we're gonna copy like settings. Okay. So this. Oops. Go back to our processing sketch, and we'll have to open another processing sketch to get the guts for Sound Cipher in. And Sound Cipher is the program or the library that's used to generate actual notes, and that's what we'll be doing. Okay. So we're going to replace W and H with pix width and pix height, because again, I'm kind of just copying their example. And so then they use settings. There's a void settings with background. Okay, so yeah, let's make the background black, or I guess it will probably be black. And then copy more of their example code and just see what it does. I mean, like at this point, we just want it to run. So image size, we said pixels. I wonder what the difference between, what's the difference between points and pixels and picas? Picas. How appropriate. 23 by 56. Okay. So let's go back. Width is 23 by 56. Again, this is just so that I can kind of have an idea of our well, that's the width and height of our Missingno image here. Okay, let's see if this runs. No, we need to do an x equals 0. Bum bum. Okay, yeah, so this is popping up on my other screen here, but I'll drag it back on. Okay, so that looks like about the right proportion, right? And what we want to do is, the reason why I'm using this settings is because I would like to scale it up. And this is something I was thinking about earlier about, like, we wanted to work with these constraints of like this 23 by 56 grid, but I want to make it bigger. So in float, pick scale, and we're just gonna do that, and I'm gonna scale it by 4 times. We're just gonna do that so that way, like, we're still kind of working in the numbers that we want to work with, but the picture that it actually renders will be bigger. Okay, yeah, and it doesn't like the float. I guess we'll just do an int. We don't really need a float for that. Okay, that's actually still not as big as I would want it to be. So if we did like an 8, how big is it? Yeah, that's a bit bigger. Okay, so now you can see processing is giving me this. Now I'm gonna save my processing project. We're gonna call it missing notes. Get it? Missing notes. And then what I'm gonna do is, now that we have that all together, I'm gonna export our GIF, our GIF. And the reason why a GIF is good for this one, or ought to be good for this one, is that the way GIF files work is that they have a table of colors that they reference, and so that's makes them handy, in my opinion, for handling web data, web data, just data in general, when you have data encoded into an image, because you can see this color table right here. We've got white, it's kind of orangish, purplish, and black. And from what I've seen and know about the Game Boy, yeah, there's 4 different, there's on and off, and then there's 2 kind of grayscale values. So if I recall correctly, by the time we import this GIF into processing, what it's going to do is allow us, well, it's going to give us an array of 0 through 3, a 2-dimensional array of 0 through 3, and then it will, from that point, it'll basically have all the color data encoded and referenced. So like, I think white would be 0, and then this will be 1, and then this will be 2 and 3. So yeah, I think hopefully that makes sense here. It's a good way of, I don't want like to save as a JPEG or anything with any sort of compression that isn't controlled, because of how we're going to have an issue with, we really want the data from this, is kind of the whole point. We want the data out of this image. We're going to actually redraw the image in processing. So, okay, so missing no crop.gif. Okay. So now go back to processing. And again, I'm going to pull up. I don't know who else is in here. Whoever's watching. It's not telling me on my end, but hi. Give us a shout out in the chat if you would. It'd be nice to have some company. And I'm going to go to processing and import. See how to import images. And it's like you use a, P image is I think the object. So we're going to go P image Missingno in like that. And then we do Missingno. So then in our setup, still have my mind blown by this settings thing. I never knew that. It just goes to show you there's always new stuff to learn in whatever you've been using for a while. So yeah, Missingno in equals and then we say load image of, and then what did we call our guy here? Let me go look that back up. Again, yeah, sorry if you're expecting something more interesting. Yeah, I get the feeling I will end up cropping this down. In the meantime, I hope you're enjoying the sounds of Breakforce One. I keep playing music from friends of mine in case anything gets flagged for copyright, so we can all just like have a good, laugh about how like they don't even own their own music. As kind of bleak as that is. All right, so I found the file name again, blah blah blah, and GIF. And again, my understanding / hope is that we're gonna be able to import all the data from our little Missingno cropped GIF here. So that seemed to work. I need to go look and like figure out how to get, the pixel data. There's this function load pixel, I think it is. Load pixels. And that's right, yeah. So we'll do that right after. We'll do so Missingno underscore in dot load pixels. And from my understanding, again, processing when you do this is gonna basically make a one-dimensional array that is it's like kind of doing this typewriter. It goes across all the rows and then down a column, all the rows down a column. So what we should be able to do, and if we really care, why don't we turn on the rulers here, turn them onto pixels. Okay, cool. Look, this is sweet. And we can start to look at like what, we can check some random variables. So why don't we go back into processing? And okay, so then the way that we access the pixels is into void draw. Well, we can use this Missingno underscore in dot pixel. And then we enter in some value here, right? And then this will supposedly give us the data. So let's see if this runs. No, it doesn't run because why? Because it says, oh yeah, we're in settings, we're in setup. We load the pixels. Maybe we do the circle brackets. Man, yeah, coding on the air is great. Super great. Super great. Okay, so we have our Missingno.pixels. And this is the function. Pixels does not exist, which is bizarre to me right now. Why doesn't our function pixels exist? Is this like a... Oh, that's why. Well, no, it should still... Yeah. Insert. We can't just... Okay, maybe we need an int to assign it to. So, you go int GIF index buffer. And then why don't we see if that likes it? GIF index buffer equals this. Okay, likes it a little bit more. Okay, it compiles and runs. Okay, cool. So now we're gonna do print line and start testing our theory about, you know, this kind of thing. Okay, so -1. Interesting. So 0 should be this right here, right? Luckily, I'm liking that Photoshop has given us this offset. So why don't we try 7, right? And my thinking is that we should be able to try, you know, any of these numbers here. And we'll start kind of building it out if we are indeed getting the data that we're looking for. Bump, ba bum, bum, bump. Okay, so I think we are getting the data we're looking for. It's not coming to me in the form that I want, because again, I wanted this GIF index number in processing. That 1677 is telling me that I am actually getting I think what I'm looking for, because if we do 8 we'll get -1 again, I think. Yeah, and then if we do like 11 then we'll get whatever this purplish would be. Really, this isn't like that big of an issue, because you know, at the end of the day we can just reference and use you know, these other numbers basically that we have. And actually I need to open in Photoshop our missing no crop is that what it is? Missing no crop, like that. Yeah. Opening that because this should have, just looking at the colors I couldn't tell if it was an optical illusion or not. But you know, our the blacks didn't look like they're the same color. Okay, so this seems to be working. We're gonna do I'm gonna make 2 more variables here. Int there's row and there's column. So we're gonna do pix call index equals 0 semicolon int pix row index equals 0. Okay, so what this is gonna allow me to do, and you'll see I'm gonna do replace them in here, pix call index plus, and then we're gonna do pix row index times 8. And that's because if you know, or I'm sorry, actually it's gonna be 22 times 23, because pixel 23 is gonna be, well, index 23 of the pixel data is gonna be the next line, right? Times 23. So this way, hopefully, can set the number that we want to set. Set the numbers that we want to set up here, and then it'll print. So if we leave that column index at, well, we want the column index of 7 and the row index of 0 should give us that 1677 number again, and it didn't. So something's wrong here. I'm guessing I mixed those 2 up. I did. Okay. So this is the row. Oh, okay. Yeah. Okay, so yeah, we got the black again, which is good. That's what we're looking for. And then I want to test it by saying, okay, we got 8 and 4 right there. So if we go back into processing and we look at, this would be column number 8, number 4. We got that 6723,943. Okay. That's good. And then I wanted to go one more column back. So 7-5 is going to give us this yellow color. Yeah. And then if we go like one more column over, it'll be this. Now, one thing I didn't think about, white. Yeah, that's good. One thing I didn't think about is the fact that once I start using, well, we'll just have to see actually. Let's, I don't have the, I don't think I have processing set up to work and give sound through, so that is working. I'm really not sure why that's working. Whatever. Okay, so you'll be able to hear the notes once I start them off. So, okay. This is good. We've basically gotten our GIF data, I'm fairly confident, into our processing sketch, right? So the next thing I'm going to do is we're going to redraw it all, which is going to be a little tedious, but it's the best way to know that we're working with the data, and we will, why don't we just go ahead and put it in the, yeah, this will be easy, or whatever. Okay, so we have rect. We want to make sure, I know that it's like a mode thing in rect mode and processing where we're going to draw this, we're going to draw them based off their corner locations, okay? So we're going to use this line, rect mode corner. Bump, bump, ba-dump. Under our draw thing, right? Okay. Oops. Anyways, it's just rect mode corner. Okay. And then we can do fill. So our background right now is black, so 255 if we're in, you know, assuming, I think default is RGB mode. Yeah, that's fine. And then, so if we do corner mode, I'm pretty sure that the first two parameters, interpret the first two parameters of rect as the location of the corner. The third and fourth are the location of the opposite corner. I don't really like that, to be honest. Corners. Oh yeah, okay, so corner is what we want, because I just want to give it a constant. Like, okay, so I'm gonna type in rect, and then we're gonna say 0, 0, and then let's see, we're gonna do, let's kind of some arbitrary thing that we can tell the dimensions here. Okay, so this should draw a little white rectangle up in our corner, and it does. Look, perfect. Okay, so now we're gonna say, I'm gonna replace this with our pick scale, right? Because that scale is really gonna be the actual size of each pixel, because we have a pick scale of 8 because our thing is ballooned up 8 times. And so this way we can be sure that we're starting to draw a pixel, right? So, okay. What we're gonna do now is animate the drawing of Missingno into our window here. And the way that I'm gonna do that is we have this ability to call our data here. We're going to copy that out of this. This is up here. It's just a reference, right? And so we need to have this counter. We're going to call it int pixel draw index equals 0. And so the nice thing about pixel draw index is that it's just going to draw. We can just increment it, right? Pixel draw index, because remember our data inside of this buffer array is just a list of, I think it'll probably, yeah, let's let it freeze. I mean, that's pretty cool and symbolic, being that it's about Missingno. But yeah, so our pixel draw index is going to just go from 0 to whatever, 23 times 56 is, and keep outputting that, those values. Now, the difficult thing is we need to draw a rect who's in the position of our pixels here. So the reason why I like this rectangle mode again is because we're not going to change the width and the height. They're always going to be square like that. But we need to increment basically our height and width depending on our index, right? So why don't we go through the first line here? Pick scale times pixel draw index. And what I think this is gonna do is draw the first line and then probably, like, it's not gonna crash, but it's going to oh, we forgot to add in an incrementer so that this pixel draw index goes up every time. And so it should draw the first line and then go off, right? Okay. And then we're missing another essential line of code here, which is we're going to say no stroke. Okay. And then right like that. So then now I'm drawing it. Okay, you can see it draws a line. And then now, I don't know if this is going to work, but we're just going to try it. And I guess this is a practice called code golfing. It's funny, a friend of mine just sent me this thing where he's like, oh, check out this little web app. You kind of just guess when you're coding. And I was like, isn't that how you do it? But again, it's even more appropriate, oopsie daisy, that we're, playing with some glitches and letting things crash and stuff while working, honoring Missingno. Okay, so this is, our first exciting moment, and I took a risk here. I guess the risk I took is that we're getting this integer back from the pixel, Missingno underscore in.pixels, which is the pixel data, and we're storing that in an int, but Phil can interpret that int as it's what it needs to be, which is turns it into a color, and then so that's why we're getting our first line of, oh look, it's Missingno. Okay, so cool. Now, like we expected, we crashed right over here at 1288. Cool. We could just set this to reset, I guess. But we're almost there. We need to, again, find a way to increment the all right, what am I trying to say here? We need to adjust it so that the pixels go down, right? And one thing I'm noticing here is we need to have a modulo function. And I love the modulo function because the modulo function lets you have things go up, 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 like 1, 2, 3, 4, 5, and then back to 0. It's a good reset thing. And again, I'm kind of code golfing here, so just forgive me. I don't think anybody's watching this right now anyways, but yeah, I'm kind of just trying this out. And then we also need what's called the floor function, which is a discrete division function in processing, right? Or I think we can just divide. So why don't we code golf this one into an existence here? So in order to get the y value, like, you see what I'm doing here? Let's see if this works. I'm just doing it. Okay, so it didn't work. But what we need to do is take that pixel draw index. See, okay, we're getting these two confused because we need the pixel draw index here. Pixel draw index there, and then the pick scale. Yeah, oops. What is up with that? Okay, pick scale there. And then we're going to copy that, and then I just replace the modulo with the division divided by 23, because yeah, we'll see if that works. Yay. Okay, so look, now we're getting our thing drawn. Oh man, yeah, the reason that works is because when we, you know, get to our well, when we get to this pixel draw index gets to, it's a integer, and so divided by 23 for anything less than 23 is going to be 0, and then it gets to 23, and then it's 1 until it's 46, and then we multiply that by the pick scale. So this is a really exciting moment now. We have redrawn Missingno in processing. We have the data there. We can see it's really kind of the same thing as our guy here, right? You know, the big advantage being that we have all the data. We have the data inside. But yeah, you can see the pixels line up, which is great. That's the first thing that we want, and it's what lets us know essentially that we have extracted the data correctly. Okay, that's actually not entirely true, because we are kind of just, there could be like variations in the color that we're not accounting for. I'm assuming there's not. I'm using that GIF that only has 4 colors. They should be exactly 4 colors because there's no compression. But yeah, so that's kind of, I think we got that covered essentially. So next thing, now that we have that, just for gits and shiggles, let's change the color mode to HSV. I just want to see how HSV, HSB, hue, saturation, brightness, whatever they call it. They call it HSB in processing. But yeah, this will just give us some weird colors, essentially based off of that same these same integer values that will be, they're not random, but looks like it didn't do that, which is an interesting thing. I was assuming we were in RGB. I don't know if that's gonna affect it. Okay, so that isn't. So there's a couple ways I guess we can go about this. So why don't we do, I'm gonna do my own color table. So we're gonna do color, or I'm sorry, we have to define it as okay, yeah, color is just an object. So color, we do index 1, and I guess I'll just define what these are. And you know, this is so that way I can also, I'm going to prove essentially that we have this data flushed out in here. And so inside of my setup, we can change the color mode to HSV, HSB, HSB, okay. Hue, saturation, and brightness. So then I can take, we called them color index, we got index 1 through 4, right? Index underscore 1. I'm just going to copy that line. Bump, 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 bump. And then we can do, I guess you can do CHSB like that. Does that work? No. Bump, 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 bump. I forget exactly how you do. Just call it a color. Search the processing color thing, and we can see exactly what the thing is. So color, blah blah blah. Okay, so I guess if the color mode is already like this, we can do HSB, so 0, and then we're going to do 255, 255 for all of them on the saturation and the brightness. So that way we can just change the hue. And so this should go like, you know, if I'm just ballparking approximate. I mean, it's not even. Yeah, let's do, I guess, what's 256 divided by 3? Let's just do multiples of 50 so I'm not hurting my brain over here. All right, 100, 150. So this will give us, you know, and actually, if we really do want to make our lives easier, why don't we do this? Instead of that, we're going to do the, change the brightness so that the brightness of the first one is 0. The brightness of the second is, gosh, yeah. 96 and then 192. Is that how that works? I don't think so necessarily, but okay. And so now we have this kind of problem again where we don't have, we need these number values to compare against, and we are getting this variable here. Okay, and so we're gonna use a switch function, but we have to I'm going to have to get these actual values. So I know that one of them is -1, and one of them is 16,777,256, right? Depending on which ones we choose. So, and then I got to write down these other two numbers so that way I can index them. And yeah, again, you can't see it on here. It keeps going off the screen, but there's it drawing itself. It really is satisfying to see that, right? Okay, so again, what we're gonna do under this GIF index is we're gonna do a switch, and then I'm gonna just write these down so I know them. -1, and then we have blah blah, and then we have this. What is it? 16,777,256. We'll find out in a second here. Okay, so we have our test variables up here. To be able to just get whatever we want. We're going to go back to 70 to get the value of one of the black pixels. It's printed in there. Okay, 216. -16,777,216. Interesting. All right. Negative 256, 216. If you don't know, is a Cleveland area code. Okay, so now we got to go to like 11 in order to get that purple. And this is, I don't like this method, to be honest with you. If I wasn't doing this live, I would look for a different way because, like, I wanted it to really reference the actual, the index of the colors. And we're stripping it out, but we're stripping it out assuming that we have this exact GIF with these exact colors, which is why I don't really like it. But, you know, we'll live. We'll just handle it. So we got our purple as this number, right? This 672 whatever, and then we got to go get the other one, which I looked was like 7 and 5, gives us our peach, right? And we will be able to tell if we have this kind of compression color issue I'm worried about here when we do this, because what we're gonna do is have our colors be we're gonna have it look up these different colors. All right, and then we need to have one more color in here. That is our color buffer. All right, which is gonna get written. And then I'm gonna Google the syntax for a switch, switch whatever in processing. All right, and then I look at it for 3 seconds. I'm like, oh yeah, okay, so switch. And so we're gonna switch our GIF index buffer up here. Cool. And then we have 4 different cases, right? And so then this is where we do case -1, and we say our color buffer equals index of 1. I think that was the name of it, right? Color buffer and index _1. Yeah, perfect. Man, I can even display. I'm gonna pretend to be a responsible coding adult over here in a second. Y'all see. And then we have our default. Oh yeah, we need all of our breaks down here. Yeah, how embarrassing would it be to do this with people watching and have all these little code mistakes? Just kidding. You gotta be able to make mistakes, I think, in front of people, or you'll just never do anything, you know. All right, so we have all these cases. We're not done. We're still cleaning up, putting some stuff in. We got to have our default in here. And this is where I'm just going to be like, oh, look, my little warning message. It'd be like, warning. Warning. Color variation. I almost said Colorado. Okay, so this will give us a little error message in case, like, we get a color that's not any of those, right? And again, I'm hoping this whole thing compiles. Why is it giving us these cases? Duplicate case. All right, we're fine with that. So now we go up to here. Bum, 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 bum. And start switching these ones in for the different cases. Interesting that we get a duplicate case error. And then we're gonna have to change those color indexes. And then hopefully, if we did everything right, which I think, you know, I probably should have tested parts of this before, hoping it compiles now, we will get a grayscale Missingno. Okay, so not quite. We missed one line of code, which is to replace this fill. And we want HSB, I think, still. Why don't we just take this out? And then we're gonna do our color buffer in here. And then now, bum bum bum. Okay. Grayscale, no, but red scale, yes. And that's because we have our saturation at 255. If we do it at 0, is that gonna give us? I forget. I mean, hue, saturation, and brightness. I mean, is totally unsaturated, but all the way bright. White? Grayscale? Yeah, okay, cool. All right. Ooh, it feels good. We got Missingno drawn here in grayscale. I'm going to Google something else real quick, just because I can. And I'm sick of this jumping to our next monitor. Blah, blah, blah. And I don't even know. Use. Bum, bum. I guess maybe I have to go into my display settings. I already thought that I had, you know, this as my primary monitor. Whatever, it's not that big of a deal. Anyways, yeah, so this is now, I'm kind of celebrating because got some good control. We can do our color scale. This is, you know, only really the first part of this, which is to say what we really needed to do is get in here and get proof that we had, you know, our whatchamacallit, our data from the Missingno image inside of processing, right? This is gonna give us a nice, like, weird temperature rainbowy one. But is it just me, or are we missing? Are we missing numbers? We are. So now okay, so we have a problem here. Houston, we have a problem. And the problem is that right now we're not seeing any delineation between black and white with this one. And why is that? Why is that, ladies and gentlemen? Because we went from 0 to 256 on the hue. And the problem is I tried to divide by 3, which gets us right back to where we started, which is why you should be dividing by 4, which is going to give us 64, 128, and 196, right? Maybe, not quite. I don't really care. Okay, so now we see the delineation that we're looking for. Again, beautiful. Beautiful. If you're like me, you like QR codes. You like data stored in, you know, images. It's very cool. It's always interesting to me what can and can't be preserved. God, I should put a line in here to end and just do this like exit before we get to here. We should just say, you know, if this equals 1288, that we exit. We should do that because it's best practice, and let's see if we even did it right. Because my point is it's crashing when it gets to the end of the GIF string, which is like really not great to do, right? But my point is that this is a friggin' Missingno tutorial. Like, you know, you gotta crash. You know what I mean? Like, it's a glitch. We didn't even do it right. It kept crashing. So that's cool, actually. Okay. So, regardless, kind of just yammering here. You know, we're almost at an hour. This is surprising. Interesting to me also to kind of time it out. Okay, so that helped, except we didn't really want to like exit. We just wanted to stop. Is that a command? Sure. And then so I'm going back to change these colors so that way it's gonna be a brightness on a grayscale just for kind of more closely resembles what I want it to resemble in the sense of oh yeah, we gotta turn the saturation all the way down, just so that way we're kind of like seeing it like an amplified index, because now we have colors indexed like we want it. Okay. Okay. So, thank you. Welcome to the first part of the Missingno into processing tutorial. We are coming in at about an hour. I guess I'll just like, maybe I'll stop. Again, I don't think there's anybody in here. Maybe there's another TTV viewer. I wonder who that could be. Wow, that person has a lot of followers. Interesting. Hi, sorry. Wow, I just stalked you on air. How are you doing? You're the only one in here but me. It's just you and me, pal. I hope you're enjoying this stream. Okay. So, let me talk to you about my next idea. Okay. Which is now we're essentially scanning through Missingno. And the idea of how we would turn this into music is that in the same order that we're drawing the pixels, we would play a note, a different note depending on which pixel it was, right? So I'm going to open up this project here called Shimmers that I guess we'll turn off our music here and go into this one, quiet mode. We go from okay. Again, I'm kind of mystified that this works, but it doesn't really matter. All that matters is that it does work. Maybe it doesn't work. Don't matter. What matters is that we're doing it. We're having a good time doing it. All right. So I'm going to get the guts from our Sound Cipher. And what Sound Cipher does, the Sound Cipher is a library that lets you play notes inside of your project, right? So Sound Cipher is a way for processing to generate musical scores. Okay. So what I'm going to do is copy our Sound Cipher thing in here. I'm going to have to go pull up ye old Google, and I don't even know, to be honest with you, if Sound Cipher is still getting supported. I would be obviously pretty sad if it ends up not getting supported anymore. But you know, it's just gonna be it, I guess. Something will take its place. But yeah, so I need to look up like the add note kind of method, whatever it's called, in order to add and basically write what would be a score. All right. So yeah, a couple other things here. We go into score.tempo. We're going to set the BPM at 140. And one thing that Sound Cipher isn't really going to do that I would like it to do is to, why don't we test it? Because we're kind of getting into this situation where it's going to write a score. It's going to take the whole time to write a score, and then it's going to be like not really great. It's going to take the whole time. It's going to make the score play after this whole Missingno guy has been drawn, right? Which we see takes about 30 seconds or something like that. So what I'm going to do is just test it and play with it a little bit, so that way we can get the process down. I'm going to test it to stop. See, I've changed this line to stop after 23 pixels, and we're going to put our score.play in there, right? So we're going to add all the first lines, and so blah, blah, blah. Okay. Now I'm going to add another float. For some reason, Sound Cipher likes floats, and we say, and this is note, we'll call it pitch index buffer. Okay, semicolon. And now that we have a switch case set up for the color, it's also nice because it's going to give us a way to assign a different pitch depending on which color comes through. Now there's a different, what I also want to do after, depending on kind of how we go through this, is instead of just, right now it's going to play a note for every pixel. So we're going to get a very like, boop, 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 like a very constant rhythm, right? And what I would like to do is set it up so that way when you have blocks, that actually makes long notes. We're going to develop that in a bit. So what I'm going to do here is, how many notes is it up to? 61, 2, 3, 4. 1, 2, 3. Okay, so we're just going to set it up like a minor chord or something, I guess. I don't know. I think this should be a minor chord. So it'll arpeggiate through those, starting at C. Arpeggiate, not really, it'll play through them. Okay, so according to our documentation, we do this .add note function here, and then we do, so the start beat is going to change with our pixel draw index, right? Because we're going to keep adding these. Okay, and then we're going to say our our pitch is going to come from our pitch index buffer up here. And then the duration The dynamic we'll say is 127 and the duration should be 1. Okay, so now if my calculations are correct, we'll draw the first line, it'll stop, it'll play the first line. Let's see if this works. Wow, wonderful. It's a dream come true. It really is. Let's try something here. So I'm going to try to see if we can, instead of going and drawing this in our draw loop, which I guess I'll just copy this and we're gonna just comment this out, and you'll see in a second here we're gonna take everything that's inside a draw, which we don't, this is, you know, not, doesn't need to be done like this. I is less than 1288 and then I plus plus. How's my syntax here, y'all? Am I doing a for loop right? God, you know, it's incredible how you could be doing this for so many years and just be like, is it parentheses? Is it, you know, I do know, or I should say I'm pretty sure it's semicolons. I just forget which one is it first. Yeah, okay. All right, so now we're going to take everything. In fact, I'm going to uncomment draw and then just copy. Okay, copy, comment it, go back up. Is that, did we do that right? God. I think so. And then go back up to here and take out this void draw. Okay. And then is it like that? Does it be like, what does it be like is the question. I think what we want to do is let's take out pixel draw index. God, we're just butchering over here. Is this how it works? Oh my God. We do this right. Okay. Why don't we just leave that in there? Yeah. Ugly code. Great. Okay. So this is doing what I want, and you guys couldn't see that, but it is drawing everything instantaneously now, which is what we want. Now, I want to go back and look at our sound cipher. And just, this is like, how do we just play a note? Do we just do play note? Because I like seeing it as it's drawn, right? That's kind of the only caveat with this, is that, okay, we're drawing this whole thing instantly. We're playing it, so we're generating this big score. But I don't just want to like generate this big score. I want to watch it while it's playing, right? So score.add note, it says, I'm looking at something we can do play note instead. Hopefully, wouldn't it be nice if life was just easy? Okay, so that didn't work, right? I gotta go into the reference here and see score. We've got some variable that's not, it doesn't like. I mean, Sound Cipher has a dang. Okay, so the new sound cipher dot this is, so it's just going to be sc dot play now. Sure. And then it looks like our play note, we got pitch, ba-bump, 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 ba-bump. So yeah, I was looking in the wrong place in the reference to, so sound cipher as like the whole class. Yeah, this is cool. Okay, so it does pitch, it does dynamic, and it does duration. What do we have here? We have start position, dynamic. Well, start position, pitch, dynamic, duration. Okay, so now we should be able to draw and hear the notes if we're... Okay. Wow. That was a little violent. It was a little fast. A little faster than we would have liked. So I'm going to go back. We're going to get rid of that big ugly for loop. This is doing what we want it to do. What we aren't getting it to do is blah, blah, blah. We got to make the frame rate change. Because now, I guess for whatever reason, it, you know, didn't, it starts going real fast. Okay. So frame rate, and then we go to, what is our frames per second, right? So if it's 1 frame per second, that's 60 beats per minute, right? If it's 2 frames per second, it's 120 beats per minute. So if this is an FPS, we do 2 beats. So this is 120 BPM. Let's see if... Okay. Now, let's see. Why don't we try, like, 4, go a little faster, and we can watch this. And then the other thing is, too, we should probably... Okay, and then it stops at this 23 because we have this in here. So, backing ourselves into a little bit of a corner here, because of how, well, I mean, it's not really a corner, but, you know, different conflicting ideas, basically. First of all, one thing I do want to do is that the background should be black. I think that our, we should be drawing in white ones, right? But then we should be drawing in colors. And we're just going to do a little color distribution across the hue spectrum here. The other thing is, I guess I should turn down the dynamics. It's loud. Okay. So another idea I had in order to like make this a little bit more interesting to listen to is that when we add our note here, this pitch index buffer 1, we can take, we'll make a new value for this. Okay, so float, we're gonna call this our row pitch offset. Yeah, row pitch offset. Is that really, see, that's really interesting. It's cool how it doesn't get to that peachy one until like the 5th or 6th row, and then it really starts to it brings in like a new tone like that. So at first I thought that was an error, and then you realize like, no, it's just blank and you know, blank and purple and black. It's until that point. So the reason I made this row pitch offset one, which I hope I didn't, it's a different project. So what I'm going to do with that is before we go and play our note down here, we're going to say row pitch offset equals. So remember this pixel draw index over 23 is going to give us our row number. And then we're going to say modulo, is it 1 or 2? I think it's 1. Okay, and then we're going to multiply that whole thing by 7. So the point is, what this should do is it should switch off, shifting up by like perfect fifth. Okay, so I think it's modulo 2. This is almost gonna be like a chord progression. This should be interesting. If we can get it to work like I think it'll work. It's not working like I think it. Oh, there we go. Oh, it is working. It's just just worked different than we thought. So at this point, so we've covered kind of the whole concept at this point, right? Which is that we, are getting the data in from Missingno, and then we're doing whatever, we want with it. Essentially, the way I've chosen to make it into music now is where you get creative. I should say this is a good time to talk about kind of this idea of randomness in art and music and the encouraging of randomness. I think that can be a hard thing to do, but incorporating finding a way to deal with like noise and randomness in what you do and wrapping that in a lot of ways to try to make it like aesthetically interesting and pleasing. I think it can be a good creative tool. So again, we could take this concept a lot further. I'm happy with as far as I got it today. This has been a really cool project. I might repeat this with the Pokemon Yellow sprite. And I also might just edit this down and do a YouTube video. If anybody was watching, another TTV viewer, thank you for tuning in. Yeah, this has been really great. I think this is a fun project I wanted to do for a while. I think I will end up editing it down into something for YouTube. Also interesting, it took me exactly an hour and 15 minutes to do. So anyways, y'all, this has been special episode Chuck B TV. Who am I? Chuck B TV on Sunday. Special topics. Thanks for tuning in. I'm gonna shut my cameras off and just let this cruise for a little while. So yeah, cheers. Thank you so much.